Okay. Hi, group. How's it going?
Hi.
Good.
Going good.
Gabby.
All right. Should we go ahead and get started then?
Yep.
Okay.
Yes.
Okay. So, did anyone have any questions, I guess, on part 2?
I noticed that I made a mistake where I did for part 2, 6C, I did the number positive when it should be negative. But I think that was it.
Yeah. I mean, this section, I feel like it made more sense to me, but it was just a lot more, like, algebra
Yeah.
stuff.
Yeah, it was pretty simple for the most part.
Yeah. So I guess, I mean, if you guys, do you want to talk about anything, or I mean, I don't want to start a quiz if we're still confused on things, but I guess we could talk about it while we're taking the quiz, so.
That's true.
Should we go for it?
Let's do it. Let's just have another quick one.
Okay.
Okay. Okay. Is everybody up and ready?
No. Okay.
Yes.
Almost there.
Yep.
Alright, cool.
Yay.
Okay, I'll read number 3. The total area under a density curve must equal, isn't it 1?
1.
Yep.
It's 1.
Yeah.
Okay. Whoever's next wants to read that, I guess.
I'll read it.
Okay, go for it.
Alright. Under certain circumstances, a density curve can exist.
No.
False.
False. A normal density curve is symmetric. True.
Mm.
Okay.
Which of the following elements of the figure represents the z-score in this image?
It's at the bottom.
Yeah, see?
Okay. Which of the following elements of the figure represents the probability that the z-score will be greater than 1? I think that's...
Which of the following elements of the figure represent... Oh, isn't that B?
Yeah, that's
Oh,
what
yeah.
it's.
That's B.
Yeah.
That's B.
Wait a minute. Wait, hold on. Which of the following elements of the figure represents the probability that the z-score will be greater than 1? Oh, okay, yeah. Yeah, it is B.
Okay. According to the 68, 95, 97 rule, what proportion of the data from the bell-shaped distribution will be within one standard deviation? Not 68?
68. Yep. This is a really fast one.
I love it.
Alright.
Oh, but it's longer. Okay, go for it.
Suppose that z-scores come from a standard normal distribution. Use the normal applet to answer this question. What proportion of the values from this random variable will be between -1 and 1? Give your answer as a decimal, accurate to 3 decimal places. If the answer was 0.389, you would enter 0.389.
Okay, let me get there. Okay.
What is it? 68? That's what it wants to know? Or between 1, I mean?
So would we put 0.68 in the area?
Z-scores come from a standard normal distribution. What proportion of the values from this random variable will be between -1 and 1? What is the variable?
That's what I think. Isn't that going to be the stuff that's in the 68%?
I would
Because
think
it's
so.
between -1 and 1.
If the z-score is 1,
Isn't that the first group?
standard deviation.
Right, but that's the percentage of it. Will be 68% of it will be between 1 and 1. But it wants to know what proportion of the values.
But if we're using the
I mean, does that-
It would be like, because when I put in the applet, it popped out 0.683 for me. So
Yeah.
I would assume that's what it's asking, because it's between -1 and 1 when I highlight the middle of it.
maybe instead of saying 68%, it wants us to say 0.683.
Yeah, I think that's what it's asking. Because
Okay.
that's what it came up as too. For me.
Yeah.
0.683.
I think so.
Yeah. Okay. Alright. So suppose that z-scores come from a standard normal distribution. Use the normal applet to answer this question. What proportion of the values from this random variable will be between -2 and 2?
So then just change it to 2.
Yeah.
And it's going to be the second part.
And it's 0.955.
Okay.
Okay?
Good. Suppose that the z-scores come from standard deviation. Use it to predict the proportion of the values between -3 and 3. So 0.997.
Yep. Okay. Look carefully. Oh,
Oh, you're good.
Yeah.
You can read. I'll read the next one.
okay. Look carefully at your answers to the last 3 questions. What do you observe? As the z-score increases. Well,
They match the value of the 68, 95, 97, 99.
yeah.
I think we just proved that rule or something.
Yeah. Like it.
Yep. I think it's the values. Yeah. So the values match.
Perfect.
Alright.
All right.
I'll read the next one. The amount of protein that an individual must consume is different for every person. There are solid theoretical ideas that suggest that the protein requirement will be normally distributed in the population of the United States. The protein requirement is given in terms of the number of grams of food quality protein that must be consumed each day per kilogram body of weight. The population mean protein requirements for adults is 0.66, and the population standard deviation is 0.07. Use the information to answer questions 14 through 17. 14. Wait, is this 13?
Yeah.
What proportion of the population have a protein requirement that is less than 0.6?
Okay. So this requires a calculator.
Yeah.
Right.
So.
Just to check, this is how you'd set it up, right? I want to make sure. Like that?
It would be. Wait. Hold on.
Go ahead, show it again.
It's kind of blurry.
Yeah. But you set it up like, what is it? The point minus the mean over standard deviation?
Right.
So it would be. So this number 60 minus the mean, and then divide whatever you get by the standard deviation. So
Right.
0.60 minus
0.66.
0.66 divided by 0.07.
0.07?
Yep.
I got negative 0.857.
Yeah.
Well, I got 2.
So then what proportion of the population have a protein requirement that is less than 0.60?
So we would find the z-score and then click on it. So we go back to the normal probability outlet and type in negative 0.85714. And less than that would be, it says 0.1957.
So 0.196?
Yeah.
And then for the next one, what proportion of the population have a protein requirement that is more than 0.6? So would that just be the opposite? So
Yeah.
804?
Yeah.
I got a quick. Oh, never mind.
Wait, what was it?
No, it was. I was gonna ask how we determined it was from the minus 8.57. I forgot that was the z-score that we're supposed to get it from. So never mind.
Okay.
It was a 0.804.
Yes.
Okay. All right. What proportion of the population have a protein requirement? The grams.
So we do the same thing, right?
Mm-hmm.
Yeah.
I got z-score of 0.571.
Yeah.
Okay.
And it's what is less than that?
Yeah.
Okay. I got 0.716.
Yep.
Okay.
Hold on, what? What's it?
0.716 should be less, but the z-score was
Oh,
0.57.
okay. I see what I got. Okay. I didn't have the other thing highlighted, so I was like a little confused.
Oh, yeah. Okay. Find the probability that a random selected person will have a protein requirement that is between 60 and 70. Remember that to find the area between two values, shade the left of each z-score you calculate, then subtract the smaller area from the larger area. Make sure your answer is positive.
Okay.
So, okay. So it would be the same two z-scores, right, for the 60 and the 70?
Mm-hmm.
Okay.
What was the z-score for 70? I think I erased it on accident.
0.5714.
Okay.
But it's actually, yeah, so 0.571.
Awesome. Thank you.
And then the z-score for, oh gosh, I'm talking and writing at the same time. Okay, for 60 is negative 0.857.
Right.
Okay.
Yeah.
So,
What was it again?
negative 0.857.
For the probability?
Or
Or
the 0.60 z-score.
Oh, okay. Sorry.
Yeah, then you subtract the two.
So I think what you would do is you would get the area for 70 for the z-score of 0.571, and that area is 0.716, and then you get the area for the z-score of negative 0.857, and then you would subtract that from 0.716. So it's 0.716 minus 196.
So 0.52?
So it's 0.520, yeah,
Mm-hmm.
is what I got.
Sounds right.
I got 2.
Okay.
Okay, so you take the smaller z-score and you subtract it from the large one, and you divide those two, right? And so
No,
after you divide, oh, never mind. Okay, you don't divide.
Right.
You just subtract it. Okay.
Yeah.
But how'd you guys subtract it? Because I took the negative one first and then subtracted it from the
No,
5.
it's gotta be bigger minus the smaller. Because you don't get a negative area.
Oh, okay. I just read that wrong. Okay. It didn't help that that sentence like was in both lines, so I kind of got okay. My bad. I had a long day today, and so my brain is like really fried.
Oh no.
Only 2 left.
Yep. Okay. Now these ones trip me up. So find the 35th percentile of the protein requirement.
So what you would do is go back to the normal probability applet, type in 0.35, and the blue should be highlighted on the left side of the left red line.
So on the negative z-score?
Yeah, and then so your z-score should be negative 0.385, I think.
Yeah, that's what I got. So that would be, that's all you would put in there, right? So
Wait, how are you getting this?
Yeah. Wait, for the number you type, for the 35, right?
Yeah, for the area you'd put 0.35, but make sure the blue area is only on the far left side, so it's beyond the far left red line.
Right.
wouldn't you have to solve it for the x, though?
Yeah, so what you do then is that gives you the z-score, which you multiply by the standard deviation. So you multiply that times 0.07, and then you add that to your mean, which is 0.66. So
Can we for the z-score we can use the positive number, right?
no, you can't.
Have to use the negative 3.85 or 0.385?
Yeah, because I noticed I did this wrong on the homework. That's why I was like,
Sorry.
I got the negative score. I did positive instead of negative, and it messed up the entire answer.
Yeah. Okay.
So did you get 0.633?
Yes, I did.
Okay.
So how do we write that? Do we just like write grams next to that?
I think we just write 0.663 or 633. Because if she wanted a unit, she usually puts it in the side.
Yeah, tell us.
Oh, okay.
Okay. Then for the 80th, you want to highlight the middle section too, right?
Yeah, because it's higher up.
Okay. So 0.842.
842.
Yeah.
Okay. I got 0.719.
That's what I got too.
Yeah.
Are you guys getting that, or is that like weird, or I don't know.
It's just taking me a while to
No,
write it all down.
my calculator skills aren't as fast.
Okay. Because at first I was like, "What the heck?" But then I realized like that's like the process of it and everything.
Yeah.
Yeah.
Makes sense.
Yeah.
Okay. Is that the last one?
Yep. I think so.
Okay. I'm going to submit. Hooray! Man, we are like an all-star group here.
Woohoo! Yeah!
Wait, what was that?
We should have a party or something.
What did we put down for 16 again? Because I missed that one.
Right.
Which one?
16?
Wait. Hold on.
For which one?
What was the number of it?
0.520.
I put down the wrong one.
Oh no!
I put down a number that I had on here instead of what we figured. Okay, that's all right.
Oh no.
Dang it.
Darn it. At least it's only 1 point, and this quiz had a lot of questions.
Yeah.
Yeah. All right.
All right, group. Good meeting. I'll post the video again, and we'll see you next Monday, I guess.
Awesome.
All right, so,
Have a good weekend.
Okay.
Enjoy the conference.
Awesome.
yeah.
Perfect.
Okay, bye.
See ya.
Bye.